Short and sweet little video here. When we look at a metallic bonding, let me get a new marker. When we look at metallic bonding, we have ourselves, we've already talked about this sea of electrons, and we have all these metal nuclei sitting here like this. And that metal's gonna have a certain type of behavior, a certain type of malleability, certain type of conductivity, certain type of ductility, all that type of stuff. Well, what we can do is we can make an alloy. And if you remember in class, we made like gold pennies, we made silver pennies, etc. But we can make an alloy. And there's two types of alloys there. There's what we call a substitutional alloy, and there is an interstitial alloy. Not really a big deal. It's not a very big section, but one of the things we can do, like when we made our brass, we took zinc and we pushed it into the copper. And so as a result, instead of it just being a copper, what we did was we replaced some of the nuclei by squishing them together, making a solution of the metals with some of the zinc metals. So some zinc atoms are now intermixed with the copper metals. And what we say is this is now a substitutional alloy. We substituted some of the zinc atoms or copper atoms with zinc atoms. And what does that do? It just changes the behavior. It changes how that metal is going to behave. It might change like what we call the sonorous nature of it. So like how it sounds, like brass instruments would sound differently than a copper instrument. Now, we could also take a bunch of atoms. So let's say this is iron. And if you notice, in between the iron atoms, there's spaces. All right, and so one of the things we could do is we could add material into it. And so one of the materials we add into like iron is we add carbon. And so we can add carbon, and carbon starts to fill these spaces in. And when you put that carbon inside those spaces, we call this an interstitial alloy. Now, a couple things with that real quick, just kind of a side note here. If you put a lot of carbon in, more carbon that's fitting inside of here, they kind of create some stiffness to the structure. So the more carbon you put in, the more brittle, the harder that iron is. The less carbon you put in, all right, then the softer this is gonna be. So this is like what we call like wrought iron, like that ornate iron that you wanna be able to shape into like really pretty fences and stuff like that. This is what we use for like wrought iron. It's iron with a little bit of carbon. And then we start putting more and more carbon into it, hammer it in, more and more carbon inside of it, mix it in. What we end up getting is we get that carbon to be harder and harder and harder for things like blades, etc. When it comes to making a sword, you want to have this right amount of carbon and iron to make this perfect type of steel. Because we want the steel to be strong enough to not bend, but we don't want it to be too hard, because what we don't want it to break. We don't want to be in a sword fight and then all of a sudden somebody comes by and hits it and pink, it breaks right off. But we also do it when we're in a sword fight. Somebody hits it and it bends, and now you're fighting with like a little hook there. And so the edge of the blade would start to dull down really quickly with every strike. So that's where these blacksmiths, these sword makers, they'll make a good combination of an interstitial alloy that gives it the proper behavior that we want. We talked about before, this is what Andrew Carnegie did extremely well with the Bessemer process. He was able to create steel and create these big giant skyscrapers with this interstitial alloy.